Hey guys, welcome to question MM226 of the Maths Methods 4 to 5 study guide. Now we've got a tin can here with a closed lid, and it's made in the shape of a cylinder as shown below, or just here, with the radius of the lid r centimeters and height h centimeters. The volume of the can is 192 pi centimeters cubed, and we need to, as part of part A, find an expression for h in terms of r. Awesome. So, first things first is to recognize that we need to use this volume within our equation, right? Because we need to relate h with r and vice versa. And the only way that we can do that is if we have proper numbers here telling us, what the relationship between those two is. So, first things first is that the volume of a cylinder is equal to pi r squared h, right? Because you get the area of the top and then times it by the height. But this is basically here is where you get your first mark, because we need to recognize that we need to use this, right? So it means that if the volume of the cylinder is equal to this, and our volume is 192 pi, it means that 192 pi is equal to pi r squared h. And what we're trying to do is find h in terms of r, right? So we're trying to get a value for h. So what we do is we divide both sides by pi r squared, and we end up with h equals 192 pi over pi r squared. These pi's can cancel out, and we end up with 192 over r squared. That's our second mark right there, and that's part A done. Sorry, part A was 2 marks. That's part A done. So basically what you want to do is get your volume or your surface area or whatever value they give you, and then come up with an equation that can relate those two together, and then solve for whatever you're trying to solve for. That's part A done. Let's move on to part B. Alrighty, so part B asks us to find the surface area. So it tells us that the total surface area of the can, so part B, 2 marks again. Surface area, so show that the surface area, A, is equal to 2 pi outside of r squared plus 192 over r squared. Awesome. So let's just get rid of this. Sweet. So first things first, the surface area of a cylinder is given by the top and the bottom areas, and we know that because we have a closed lid. So the area of this is pi r squared, and we've got 2 of them. So 2 pi r squared plus the circumference multiplied by the height, which is 2 pi r h. And if you're not too sure about this, just go and review your geometry stuff. So 2 pi r squared plus 2 pi r times h, where h is equal to 192 over r squared, which is what we found in the previous part. So that's our first mark right there, and our second mark obviously comes as we go along. Actually, it's not SA, it's just A. 2 pi r squared plus, so where do we want to get to from here? We want to take 2 pi out as a factor. Cool. So then we can get 2 pi times r squared plus 192. Actually, this is meant to just be over r, my bad. 192 r over r squared, which then gives us 2 pi r squared plus 192 over r, as required. And that's our second mark. So that's it for part B. Let's move on to part C. So part C asks us to find the value of h for which the tin has the minimum possible total surface area. Awesome. So part C, and this is worth 3 marks, guys. So pretty long question. Alrighty. So we know that we need to find the minimum value of h, but we don't have anything in terms of h, right? So because we don't have any of this stuff in terms of h, we're going to need to find the value of r, which gives the minimum surface area, and then find our value of h based on that. So we know that our area, or our total surface area, is given by 2 pi outside of r squared plus 192 over r. And if it's a minimum, as in the minimum possible total surface area, that means that a dash of r is equal to 0, right? So our derivative of this function is equal to 0. So let's just rewrite a as 2 pi r squared plus 384 pi r to the negative 1, because we do not have a calculator, which means that we have to derive this by hand. So a dash of r then is equal to 4 pi r minus 384 pi over r squared. Awesome. Now, we need to make this equal 0 for the minimum area, which means that 0 is equal to 4 pi r minus 384 pi over r squared, and that's our first mark. Rearranging this, we get 384 pi over r squared equals 4 pi r, and then what we can do there is multiply by r squared, which gives us 384 pi equals 4 pi r cubed. Let's just go back up here. Whoop. Let's just go back up here for a second. We can divide both sides by 4 pi, which gives us 384 pi over 4 pi equals r cubed, which means that r cubed is equal to 96. Awesome. So r is equal to the cubed root of 96, and that's it. So because we don't have a calculator, we can just leave it as cubed root of 96. And our units are centimeters, so our radius, when the surface area is at a minimum, is the cubed root of 96, which is our second mark right there. But we haven't answered the question, because the question is asking us for the value of h, for which the tin has the minimum possible total surface area, which means we know that there is a relationship between h and r, right? We know that h is equal to 192 over r squared, which means that h is equal to 192 over cubed root of 96 over, squared. Awesome. From here, we can kind of rearrange all this, and we end up getting 192 over 96 to the power of 2 over 3. That's what this bit here is. And 192 is the same as 2 times 96. 96, 2 over 3. So this 96 and this 96 can actually cancel each other, or not necessarily cancel, but they minus from each other. So according to our index laws, h is going to be equal to 2 times 96, 1 minus 2 over 3. Which is 2 times the cubed root of 96. 2 cubed root 96, which is our h value. So this is our third and final mark, guys, because we were asked for the h value, not the r value, and this is our final answer. Guys, if you have any questions about this, please hit me up in the comments below as always. But otherwise, thanks for watching and have an awesome day.